Hello YouTube. Okay, so this video tutorial I'm going to look at one of the very first projects that we work on in Khan Academy. What's for dinner? Now if you read this, it essentially says just use what we've taught you so far and draw us something for dinner. And they give you a table color and a couple of ellipses, which constitutes a dinner plate. So it's always good to write out a plan first if you are just starting from blank, but you have an idea of what you want to do. So I started out by listing some popular dinner items that people on this project tend to draw. So for example, eggs. You might draw like some ellipse that's rotated some angle and another ellipse inside of it, and color the yolk yellow and the outside some kind of creamy white. French fries, you might try drawing like one of those cartons and have like some rectangles, but like cut away part of that, and then have some other rectangles sticking out of it and color them yellow and have them at different angles. So what different kinds of shapes? I believe directly sorry, I'm losing my voice. Directly before this project they tell you about the documentation, and I'll just point that out once, but they should have already told you. Down here you have some tabs, like this is where you can request help, and this is where you can see all the documentation. So if you click on the documentation tab and scroll down, you can click any of these buttons to jump to a specific part of the documentation. That, for example, this tells you all about how to text things. Well, not all about, there's probably some other stuff. Text align, for example, I don't see in there. So it's not a comprehensive documentation, but it's really handy, and it all fits right below your programming environment. So while you're programming, you can just say, oh, I don't remember what all the shapes there are. Give me a list of shapes, and then you can see all of these. And then I like to occasionally look at the actual documentation page for them, because they'll give you examples on load, please. They'll give you examples on the usage of the shape. So rect, for example, you can also click inside the parentheses and see this little pop-up, and then get a little description below if you hover over the parameter. Things that you put in functions are called parameters, and we make shapes using functions. So enough about that. So I just listed some shapes. Here is a very common question for this project. Why aren't my shapes showing up? And a lot of times what someone will do is, well, more often than not it's some kind of syntax error, and they have some kind of error, but a lot of times they just don't understand why they can't color them. So you need to know about this function. This is very, very important. Fill tells your program what color you want the shape to be. It's just like background in that you give it an RG and a B value between 0 and 255, or you just pick a color using the nifty pop-up. And then from then on, after the fill statement, every shape you write will be colored with this color until you write a new fill statement. So just as an example, so this one is going to be colored blue, and if I put another, here's another nifty little tool, a little pop-up box, and if you select something and then hit enter, then it auto-completes that. Or if you click on it, then it will auto-complete that. Don't trust autocomplete always. Always read the code yourself. Sometimes it messes up. So here are some random shapes, and well, it's not going to draw until I clear the air. You can't just write random stuff. It has to be syntactically valid, otherwise the parser will just give up and throw an error. So this ellipse is the same color as this rectangle because this is what we call a pervasive function. As soon as you set it, it remains, the property that you set remains true until you set it again. But there's no problem just calling fill multiple times. That's kind of what you're expected to do. Unless you want the shapes to be the same color, then it's okay to just call it once. You don't have to call fill again and again and again, fill shape, fill shape, fill shape, unless you want all of the shapes to be a different color. Now if I want another ellipse, it's easy to just copy the code and then reposition it somewhere else using these slider bars. Alright, now let's try and make, how about some pizza? That's the first thing on my list. So pizza, a lot of times what people try to do initially is they'll make some kind of triangle and then they'll put some circles on it and then they'll give up. Pizza is often, not always, but it's often made in a circular pan, and then you just have a slice of that pizza. So if you check your documentation and look at this function, and you read the description on that documentation tab, it'll tell you that arc is kind of like ellipse. You give it a point for the center of the arc, and you give it some dimensions, width and height, and you give it these two other variables, start and stop. And that tells the computer what chunk of the arc you want. So if my arc had this center and dimensions, and I gave it this angle and this angle as my start and stop, then I would have this chunk of the pie. So you can fill arcs, and that will fill out this interior, or you can call no fill, or you can call them before a fill has been set. Let's just take one of these. So I took that one right there, apparently, and I left the fill color from that previous rectangle. And I am going to select a more pizza-like color, or bread dough, I mean. I have no idea. Well, we'll just say our bread dough is kind of zesty, so it's got some extra orange in it. Okay, now look at these x, y. So these two parameters tell me where the center is. So I'm gonna just set my pizza slice to be right in the center. And I don't want to eat 3/4 of the pizza, so I'm thinking that 1 starts at the positive x-axis, so 1 angle down from the positive x or degree. I believe they work in degrees by default in this. So 1 degree down, and then stop 270 degrees around. So this would be 180 degrees around, so this would be 90 degrees around. So let's try 45. Now what if I wanted this 45 instead of this 45? Well, then you just put a negative number in. Or not. How about starting from negative 45 and going down to the x-axis? Apparently it can't work backwards. You need to start somewhere and then go counterclockwise. And I don't like how big that is, but remember the second and third parameters are width and height. So I'll make those about the same as the plate. Wait. So the plate, the inner plate diameter, width I believe is measured from here to here. Height is from here to here. And you might know already, but the canvas is 400. So that gives you a little bit of a reference. So if I want my pizza to end about right here, I need an ellipse with a radius that's about this much, which is about 50 less than 300, so I'll go with 250. That looks about what I wanted. So let's work on the crust. What I'm going to do is I'm going to change the color of this little region of pixels right here. That's called the stroke, and you can set the stroke color just with the function stroke. That's intuitive, right? So I'm going to set a stroke color of something darker, just arbitrarily. Maybe the stroke is the crust is a little bit burnt. And now I'm going to change how thick to draw that stroke. And I'm going to have to move these lines up above so that they will pervade down into my arc function. These are called style codes. You want all of the style codes for your shape to be above your shape. It looks like you're missing a semicolon according to ONOS. That's right there. So now I have a little bit of a burnt crust on my pizza. I think next I want to draw some pepperoni. So I'll set the style code up for the pepperoni first. If I don't change the stroke weight and the stroke, then my pepperoni is going to have this big brown region around it, and depending on how big I draw them, it might not even look like if I set the color to red, which it defaults to, by the way, once that auto-completes. Once you fill out the opening parentheses, then it auto-completes all of this for you, which is really nifty. Lost my train of thought. I was saying something about if I set this to red, the stroke around it. Anyways, I'm gonna copy this, set this back to 1, which stroke weight defaults to 1. Actually, I don't want that at all. and I want a different function here that requires no parameters called no stroke. So what that does is it just tells your next shapes. Remember, this one is also pervasive. Most of the style code is pervasive. It tells all of the next shapes, don't draw a stroke at all. So that's why I deleted the stroke weight. You know, this is also a little bit advanced. I was going to say that push and pop matrix and rotate is a little bit advanced, but I will go ahead and show you some of that stuff. Now, if this was like a rectangle and I wanted it drawn at some angle, then I could use a quad, which is in the documentation. It's just a rectangle, but you define all four of the points instead of the top left point, and then okay, so backtracking, what I was going to say about stroke weight is I almost set it to 1, but then I decided that I just wanted no stroke instead. But that reminded me that since fills are pervasive and sometimes you set up things like this and then you forget about them, it's almost good practice to just wrap up any kind of style code in these functions. Push style, pop style. Now, to illustrate what that did, basically it shielded this style to be only within these two things. So when the pop style was up there, it didn't draw that stroke, and then when I moved it down, it did. So below this, there's not going to be this style. So if I were to draw an ellipse right here, then it's going to borrow, it's going to have this fill, and it's going to ignore all of this style, and that's it. So it's just a normal red ellipse. In other words, you don't have to worry about setting stroke weight back to 1. Alright, so now we're going to do some pepperonis. So that's kind of enormous pepperoni for this size of pizza. So I'm going to scale it down a little bit. Oh, that's the position. That's about right. Backtracking a little bit, maybe I will use some transforms, because I decided I want a whole pizza. So I'm going to draw one slice of pizza, and then I'm going to rotate and draw another one, if that makes any sense. No, that'll be too hard. Trying to think of a good reason to use the rotate command. Well, I've talked about it so much I have to use it now. So put the pizza on hold. Let's talk about rotate. Now I'm going to set up some style. And a shape. And I'm just going to call rotate. Now the pop-up box is helpful. It pops up, it says rotate, you put an angle in. So I'm going to put 30 degrees. My little rectangle was right there before I typed rotate, and then it jumped all the way down here. What happened is the whole canvas, the whole coordinate system, you might have gone to school and learned about X and Y axes, and maybe they've told you about this on Khan Academy somewhere. Well, the coordinate system for this program, where it says, okay, I'm going to tell you a Cartesian coordinate for this ellipse right here, and I'm going to say that is go to the right 282 and down 200. Well, now the positive x-axis is something like right here. It's rotated down 30 degrees from where it used to be. So when I told to draw this rectangle at the center, 200, 200, well, the center of the canvas is now down here because the whole thing is rotated. You might get a good illustration of that if I'm going to put no fill just so that this doesn't cover up all my drawing, and I'm going to put a rectangle that just, without the rotation, it would draw around this canvas. But now with the rotation, it's going to show you where the canvas moved to. So 0, 0, and so that should give you a pretty good idea of how rotate works. And an example of why you would want to do that, I think I already mentioned, is like some French fries. If they were sticking out of the top of the container and they were all pointing directly up into the air, that would look kind of unnatural. So you might want to give them each a little bit of a different angle and point them out in different directions. You would do that with this rotation. Now, one of the dangers of rotation is that it's kind of pervasive. I don't know if that's actually the right term for it, but just like how style has these functions, push style and pop style, to shield the rest of the program from what you did in here, then you can also put a push and pop matrix. Matrix for, well, it's kind of a linear algebra term of, I don't want to get into that. I'm already so far off topic from drawing food. Bless you, knows. So to illustrate that, here's my pepperoni again. If I put that down here, it's drawing in the exact same place as when it was up here, whereas without push and pop matrix, it draws down here because it got rotated. Well, I hope I didn't confuse you too much. I think I'm going to end that tutorial on that overly complicated thought. Have a good day.